So for section 2.2, as we continue here, we are looking at piecewise functions. Our topic today is just to understand the notation of it and how do we use it. How do we graph a piecewise function? So for the first one, I want you guys on your notes packets to draw in the lines for parts A and B. They are in y equals mx plus b format. All right, so you should be starting at your y-intercept, that point on the y-axis, and then using that for rise and run. All right, so go ahead and draw those in. All right, so now that we have our lines drawn, what we do in a piecewise function is we say, I want to take a little part of this graph, and I want to take a little part of this other graph, and I want to put them together. Okay, so what we are going to do is we're going to use this first graph if we have x values that are less than 0. All right. We use the second graph, the y equals 2x minus 3, if we have x values that are greater than or equal to 0. So 0 is kind of my breaking point. All right. So what I would do if I were going to graph this, I would put a dotted line where my break happens. So I can visually picture, I'm going to have one shape on this side, I'm going to have a different picture on the other side. And then the first equation, y equals 3x plus 5. Which side of that break is that equation going to be graphed on? In other words, which side of my coordinate plane has values for x that are less than 0? Are we looking at the left side of it or the right side? We're looking at the left. So this is the graph that's going to be on the left side of my picture. Okay? I graph it like I normally would. I'm going to start at a 5 on the y-axis, and I'm going to do a slope of 3. All right, so up 3 over 1. Now, can I also go down 3 and back 1? And the reason I'm going to do that, and I'm going to keep doing it until I get enough dots. Okay, the reason I do that is because we said this graph should be drawn on the left side. I don't want all my dots on the right side, and then I can't tell where it's supposed to be on the left. So when I go to draw this in, I am only going to connect the dots on the left side of my graph. Okay? Now, can I use that function when x is equal to 0? Look at the domain we were given. X has to be strictly below 0, yes? So how do we indicate that we are getting really, really, really close to that endpoint without actually being there? We use the open dot. So on the end of this graph, there should be an open circle to show that I'm getting really, really close to that without actually touching it. Okay? Then I go to graph the second one. Now I want to graph y equals 2x minus 3. So I'm going to start at negative 3. And I'm going to do a slope of 2. So up 2 over 1. And I'm only going to draw this part of the line that would be on the right-hand side. Now because it can equal 0 here, all right, x can equal 0, we would have a solid dot at the end. And remember that f of x notation tells you it should be a function, right? Is this a function? Does it pass a vertical line test? And the only reason it passes a vertical line test is because one of those dots was open and one was closed. All right, that's why you have to be very clear. When you guys did the Desmos activity last Friday, I said it's not clear on there, right? They don't show an open circle and a closed circle, all right? But on paper, you're going to have to be very clear. This is open, this is closed. So basically what we did is we took a piece of this one. We said we wanted that much, that chunk of that line, and we wanted this chunk, and we put them together on the same graph. All right, it's called a piecewise function because it's in different pieces. Questions so far? All right, let's try another one. Are these still lines? Where does the break happen this time? Look at your domain. Where's that break happening? At -3. So we need a change in our graph at -3. All right, so draw your dotted line in. The top equation that says g of x equals x plus 2, which side of that dotted line does that apply to? We want that when x's are less than -3, which would be on which side? On the left. So we're going to graph this one on the left and this one on the right. Now what makes this one a little trickier is that our break doesn't happen at 0. It's nice when our change in graphs happens right on the y-axis. This one doesn't. But we still have to graph them starting on the y-axis and then using our slope. So when I graph y equals x plus 2, I still have to start on the y-axis at 2 and do a slope of 1. So I'm going to put a dot at 2. I'm going to do a slope of 1. And then again, I can go backwards, right? And I'm going to go backwards quite a bit because we said we wanted that graph on the left side. So I need enough dots on the left side that I can accurately graph it. When I hit the break, that blue dotted line, will this have an open or closed circle? Has to have an open circle. So I'm going to have an open circle here, and I'm going to draw the line in there. Those other dots, you can erase them. I'm fine with you leaving them in there. Just don't connect them, all right? We just use those to help us position our line correctly. But we didn't want all of that piece. Okay? The second one says y equals x minus 2. So again, I'm going to start on the y-axis. I'm going to start at -2. And I need to graph a line that's y equals x minus 2. So it has to have a slope of 1. Up 1 over 1. I'm also going to go down 1 and back 1 until I hit my break, because that's where I want to stop that piece of it. And then I'm going to draw it in. And do I have an open or closed dot? This one needs to be closed. So my question again is, does it pass a vertical line test? These always are going to be functions. That's what this notation indicates. So double check when you do your graph. It's really, really common for students to have both pieces on one side. And if you do a vertical line test, that should be a big red flag flying that says this can't be true. All right, I must have graphed something wrong. You can't have them overlapping like that. All right, part of this one says also determine the range. Now range are the y values that are getting used. We've given you the domain here. I circled it in blue. But the range is what y values are getting used. So I'm going to start at the bottom of my coordinate plane, down here at -infinity, and I'm going to start picturing moving upward. Are there any y values that aren't getting used? It doesn't matter which equation is using it, but are there any breaks where the y's are skipped over? So as I move upward, I've got y's being used by green and red, right? But there's no breaks. So my range here would be from -infinity to infinity. You will see some piecewise functions where there is a break. All right, so we need to keep that in mind. And then the last part for this question says it wants you to evaluate the function at some different values for x. The first one says find f of -2. That means when x is -2, tell me the y value. If you have a graph drawn, you can verify it with the graph. But I still want you to check the equation. It's just another way we can make sure that we graph things correctly. So when I'm trying to evaluate f of -2, I have to go back to my function and say which values or which function, which piece of it is being used for x values that are -2. And when I look at this, -2 fits right in here, right? -2 is greater than -3. So that means I have to use that bottom function. All right, so I'm going to plug it into the bottom one, the x minus 2, and I'm going to replace the x with a negative 2, and I get a negative 4 for an answer. Now checking on my graph, if I go to x being negative 2, am I down here at negative 4? Okay, so it seems to be right. Which function do I use for negative 3? You have to be careful on this one because you see both domains have a negative 3 in, but which one has it equal? The bottom one. So again, I'm going to use that red graph, put it in to that bottom function, and when I check, if I go over to where x is negative 3 and go down, I am hitting at negative 5. Okay. Last one says find f of negative 5. So which colored part of my graph would that use? The green part? So if I go over to 1, 2, 3, 4, 5, go here to negative 5, I should get an answer of negative 3. Which equation am I plugging it into? The top one. We need x's that are smaller than negative 3. So I'm going to dump it into that top equation, and I am getting what my graph says I should get. All right, I'm going to pause the recording for a minute. I want you guys to talk at your tables. Is there any piece of this that's confusing to you? All right, looking at the next one. Are both parts of this graph going to be lines? Our first two examples were all linear, but what do you see in that first equation? Negative 0.5x squared. What shape is that? It's quadratic, so it's what shape? A parabola. So we're going to have part of a parabola, and we're going to have part of a line. Okay. Where does the break happen? At 1. So let's go ahead and do a dotted line at 1. Which side is that first equation going to be on? On the left side? All right, because that's where x's are less than 1. And the second one will be on the right side? Okay. Let's start with the one on the right. Let's get the line drawn in. That's the easier one. What's my y-intercept? Positive 1. So I'm going to start on the y-axis at positive 1. And I need a slope of 2. So up 2 over 1. And we said we wanted this on the left side. So it's probably a good idea to go down to, sorry, we want this one on the right side. Okay, so let's draw that in. And do I need an open or closed dot at the end of that? Because it can equal, we have a closed dot. Okay, make it big enough that it's obvious you know that one is closed. All right, now to graph the parabola, what can you tell me about it? Is it going to open up or down? It's going to open down. Why? Because of that negative in front, right? That negative a value. What's the 0.5 going to do to my basic parabola? Think about your transformations. A number in front does a stretch and compression, right? If it's something like a 1/2, what's it going to do? It's going to compress it, which is going to make it look a little fatter than normal, right? It's going to basically squash it down. Okay. To draw this, you can certainly draw your parent function and then transform it, or you can just pick some values for x. If you're going to pick some values for x, we need x values that are less than 1. However, I am going to put a 1 in. And do what you need to do to indicate, maybe put a little dotted circle around that. We're not actually going to be there. We're going to get really, really close to that value. But I need to know where that open circle lands. Okay? So if I put a 1 in here, what's negative 1/2 times 1 squared? All right. So when I am at 1, negative 1/2, there should be an open circle there. What if I put a 0 in? what do I get? 0. Okay, so whoops, I have a dot at 0, 0. And what else? Let's put a -1 in. What do we get? Still -1/2. All right, so that's symmetry again. And how about -2? -2 squared would become 4 times the -1/2 would be -2. All right, so we're going to draw in that part of the parabola. Notice I started at my open circle, went up to my vertex and back around. Does it pass a vertical line test? Make sure you don't have any 2 dots lined up vertically. The open circle doesn't count, right? It means we're really close, but we're not actually at that point. So it does still pass vertical line test. Now for the range, we do have a little break. If you look right in this section in here, there's kind of a gap between my red graph and my green graph. So what is the range for the red part? Again, we always start at -infinity and work our way up, correct? So I'm starting down here at -infinity and I go up to 0. Then there's a little jump. All right, I'm going to put a little union symbol in there. So it's this chunk combined with the other chunk. And now for the green graph, what's the lowest y value I hit? I start at 3 and I go up to +infinity. All right. Which part of my function do I use when x is -2? F of -2. Am I using red or green? I'm using the red one? The one on the left? Okay, because -2 is a value that's less than 1. So I'm going to plug it into there. -0.5 times -2 squared. We actually did that in our t-chart already, right? And we got a -2. All right. What if we want f of 1? That's where my break changes. Which one do I move to? I need to move to the bottom one, the one on the right-hand side. So I'm going to have 2 times 1 plus 1, which is 3. Does that fit my picture? 1, 3. I have a dot there. Okay. And then f of 5, which one do I use? The one on the right. So 2 times 5 plus 1, we should be up at 11. Okay? All right, how about this one? How many parts are there? 3. What's the first and last part going to look like? The one that's just a 4 and just an 8. If I said graph y equals 4, what does it look like? It's not a dot. It's a line. What kind of line? Y equals 4. Horizontal line. Right? Your y values are 4 everywhere on that line. Doesn't matter what x is. So I have 2 places where there is a break. There's one break at -2. All right, we're changing that, and then we're changing again at 3. So go ahead and put your dotted lines in at -2 and at +3. So we'll just start on the left and work our way over. To graph y equals 4, we said it's just a horizontal line at 4. And I need to be over there on the leftmost chunk of my graph for x values that are less than -2. So what kind of dot do I put on the end of that? Open dot. Okay. Then I shift to a basic y equals x squared graph. What does that look like? Y equals x squared. We just graphed one. That's a parabola, right? No transformations on this. This is our parent function. Has a vertex where? 0, 0. Opening up or down? Opening up. If I plug a 1 in, I get 1. If I plug a 2 in, I get 4. And if I put a 3 in, I get 9. What if I put a negative 1 in? I get a positive 1. Put a negative 2 in, I get 4. Now, look what happened. I had an open circle there from my blue line. My green parabola is going to end up filling it in. Okay? I'm going to draw in my parabola. Will I have an open circle up here at 9 or closed? Closed. It can equal the 3 here. So closed dot there. All right. Last piece. We just want to graph y equals 8. What's that going to look like? It's another horizontal line, this time up at 8. Do I have an open or closed dot? Open. All right. So does this still pass a vertical line test? Because the open circles don't count, right? They're not. We're not there. We're just really close to being there. Okay. How about the range for this one? Again, always start picturing you're starting down at negative infinity. Am I using the values down here in the bottom half of this? No. What's the first y value that's getting used? A 0. It's being used by the green parabola. All right, so my first point is a 0. I do include it because I do have a dot there. And then what happens? As I go upward, what's the highest dot I'm going to hit? A 9, right? Now, the 4 and the 8 are within that range. Okay, so those are getting counted in there as well. All right, I'm going to pause the recording. I want you guys to go through and answer f of negative 5, f of negative 2, and f of positive 5. All right, so which part of my graph do I use for x being negative 5? The first one, the blue part. So my answer is just a 4? Yes? Somehow my board got off while we paused it here. All right. Which function do I use for negative 2? Negative 2. The middle one, because in here, right, we can equal negative 2. So I have to use my quantity squared graph. So I'm going to put a negative 2 in, and we got a 4. Okay. And then which one do I use for f of 5? The bottom one, which would be the red part. Okay. Questions about graphing it? Knowing where breaks happen, open, close circles. We okay with that? We okay with finding range? All right. I will get you guys some graph paper.